To present for you today a scientific topic. It's a new discovered subject that I think that you guys will enjoy hearing about. Before I start speaking about the subject, I need to make sure that you guys are aware of some facts. I know that you guys have heard about them before, but I'll just pass over them quickly so you can keep up with me when I start most of it. At the first, I'll talk about the Big Bang Theory. The Big Bang Theory is a theory which assumes that the universe originated 20 billion years ago from a very violent explosion of a very little amount of matter of very high density and temperature. Anyway, after this explosion led to the formation of the matter. As you can see here, the subparticles began to form. By the way, there are many subparticles in the atom. In the atom, there are not only protons, neutrons, and electrons, but there are many other subparticles. They are around 70 subparticles, but we haven't heard about it. Anyway, as you can see here, the subparticles were formed and they started joining together, forming the nucleus of the simplest elements. Then the hydrogen and the helium started to form, and the galaxies and so on started to form after the Big Bang. Anyway, this explosion led to the formation of the matter. And matter, you can define it easily. Matter is anything that occupies a volume and it has a mass. Anything around us is considered a matter. This pen is considered a matter. The water is considered a matter. The air around us is considered a matter. Abu Samra at the back is considered a matter. So anything, and by the way, the matter has 4 states. The solid state, the liquid state, the gas state, and the plasma. I think that most of us haven't heard about the plasma. The plasma is like a gas cloud of ions, positive and negative ions. And there is very strong electric attraction force between these ions. And when they collide together, they produce very high amount of energy like those we receive from the stars. You know, the sun and the energy received from the stars because the explosion with this plasma. Anyway, the thing that we don't know that after associated with the formation of the matter, something strange was formed. And this thing is my topic for today, and it is called the antimatter. Now I'll show you a video which can explain briefly what does the antimatter mean.
There is something evil lurking out in the cosmos. It's called antimatter. If one tiny drop of it met a drop of normal matter, it would explode with more force than the bomb at Hiroshima. The frightening reality is that the Big Bang should have created antimatter and matter in equal amounts. In other words, out there should be an antimatter twin to our universe with the power to annihilate all creation. There's just one problem. This deadly antimatter universe has gone missing. Joanne Hewitt is a theoretical physicist at the Stanford Linear Accelerator in California. She's a detective on the trail of this missing parallel universe.
Where did it go? That's one of the big mysteries of science today, is where did the antimatter go? Every particle has its own antiparticle associated with it. It has the same mass as its parent particle, but it has all the opposite properties. Like an electron has an electric charge associated with it, so an anti-electron, which is called a positron, has the opposite electric charge associated with it. When antimatter and matter collide, basically you get a big burst of energy, just like boom.
If the Big Bang created as much antimatter as matter, then one of 2 things should have happened to it. Any particles of antimatter and matter that bump into one another should have been completely annihilated. But some antimatter and matter may not yet have met, and an explosive reunion could be coming our way.
So as we have heard about the video, this is the antimatter. But before I start speaking about the antimatter, how much do you bet is the price of 1 gram of this antimatter? Let me hear some guesses.
$2,000.
10,000? No, go a little higher.
$100,000.
Much higher.
$1 million.
Again, I repeat the question. How much do you think is the price of 1 gram of antimatter? $1 billion? Go higher, please.
The most expensive. $2 billion.
It is considered, yes, the most expensive substance on the earth. $10 billion? Go a little higher. Let me hear some guesses, guys. $100 billion? Go a little higher? Well, the price of 1 gram of antimatter is, this is 62.5 trillion US dollars, which equals to 16 times Egypt's gross national income for 16 years. So if Egypt started saving money for the next 116 years, I think we'll be able to buy this 1 gram. So, briefly, what is antimatter? Antimatter, as you have heard from Morgan Freeman, he said that the antimatter is the same antimatter. It has the same properties, same mass, same volume, same density, affected by the same free flow acceleration. It's just that it carries an opposite charge. The electrons in the matter and the antimatter are called positrons, and they carry a positive charge. And the protons in the antimatter are called antiprotons, and they carry an negative charge. So, the matter and antimatter asymmetry. One of the greatest mysteries now in our modern physics, where did the antimatter go? It was supposedly that after the Big Bang, equal amounts of matter and matter should have been formed together. But still, that if they were in equal amounts, both of them should have annihilated each other. And annihilate means to destroy each other. So if they both annihilated each other, the universe should have been just pure energy lurking there in space. But the fact that we are now surrounded with matter and the presence of our universe for today, of course, poses the question: where did this antimatter go? There are many theories which try to explain this imbalance. Some say that somehow the antimatter could escape from this devastating collision, and now it has formed anti-galaxies and anti-life far there in the space. Others say that the matter was formed, exceeded the matter formed exceeded the antimatter by very little amount. So after they annihilated each other, there was little amount of matter left, which now has formed our universe. But of course, all of these are just theories, and nothing has been proven till now. The history of the antimatter. How did we start to think, or how did the idea of the presence of antimatter get to our minds? As you can see here, this young physicist, which is called Paul Dirac, in 1928 he found a strange mathematical equation, which is called quantum theory and special relativity. Of course, I don't know about the equation, but he was awarded, by the way, a Nobel Prize for it. Anyway, the electron, in this equation, the solution of the electron had two values, a positive value and a negative value. Of course, we know the electron should carry a negative value, but the fact that the electron in the solution had a positive value widened our mind to the presence of the anti-wall. If the electron really could have a positive value, then maybe the presence of antimatter may exist. And since then, scientists have been trying to search and to trade and try to track the presence of this antimatter. But still, all of these are just theories. Nothing has been proven yet. The discovery of the antimatter. Anyway, in 2008, NASA launched a space telescope in the space, and it was on a mission trying to, track and to take the various cosmic rays coming from black holes or coming from massive superstars going supernova and so on. But the surprising thing that in 2010, the surprising thing that in 2010 they found that a beam of positrons was coming from the Earth. A beam of positrons coming from the Earth hit this telescope. So they tried tracing this antimatter, and they tried tracing these positrons, and they found that the process of the formation naturally of the antimatter on the Earth could be like the following. This is a brief video to show you how the antimatter is forming naturally on our Earth. This is a thunderstorm, but under the right condition in this thunderstorm, you can find that the electric fields in this thunderstorm produce an avalanche of electrons. These electrons shooting upwards at nearly the speed of light. You can see the electrons shooting upwards. Then these electrons come and hit an air molecule, forming gamma rays. Then these gamma rays also try and hit another air molecule. Here you can see that they have been tracing the flashes of these gamma rays. They have been trying. Anyway, the gamma ray hit another air molecule, giving positrons, giving a positron and an electron. Then the cycle repeats. The electron and the positron hit other air molecules, forming another gamma ray. Then the gamma rays hit other air molecules, forming other positrons and electrons, and so on. And this was the first physical discovery for the antimatter on Earth. Anyway, here we got CERN. Now CERN is considered the most advanced organization on our planet. So working in CERN is the dream of any young scientist. By the way, it is derived from the French word Conseil Européen pour la Recherche Nucléaire, which means the European Organization for Nuclear Research. This organization is a multinational organization. It has scientists, it has over 8,000 sites from all over Europe, and it's also a multi-billion organization, as it spends more millions of dollars, billions of dollars yearly for the research. So they started creating anti-hydrogen. And by the way, it is logical that they go for creating the anti-hydrogen. As of course we all know, the hydrogen is considered the simplest element on our Earth. It only consists of one proton and one electron. And in the case of the anti-hydrogen, you can find that the anti-hydrogen consists of one antiproton and one positron. And so it's considered the simplest antimatter they can form. And the process of creation of the antimatter, I can sum it briefly as the following. This device you guys see here is called subparticle accelerator. It is used for creating subparticles. So when the problem that when the first subparticle was created, it possessed a very high amount of energy, and this was just shooting outwards of the apparatus, colliding with the matter, and both were annihilating each other. So the problem is that how to confine these subparticles. The process of creation of the subparticles itself wasn't the problem, but how to confine and how to trap these subparticles. So it is known, it is a fact in physics that we know that at absolute 0 degree, absolute zero is equivalent to negative 273 degrees Celsius. So at absolute zero, the particles are at its minimum vibrational motion. So they called the subparticles to this absolute zero, and they also created the antiprotons. They first created antiprotons and cooled them, and then they created the positrons, cooled them by the same way, and they were both forced into collision with each other, forming this anti-hydrogen. But the main problem is that how to trap this anti-hydrogen. The creation of the anti-hydrogen itself is no problem, but how to trap and how to confine it for as long as possible so they can start studying its properties. Now I'll show you another brief video on how they succeeded in trapping this antimatter.
Scientists at CERN have managed to trap elusive antimatter atoms for a quarter of an hour. It's a huge step forward on last year's efforts when they were able to hold the mysterious particles for just a fraction of a second.
In the first trapping experiments, we just held on to the atoms for 172 milliseconds. So the big breakthrough now is that we've held on to these antimatter atoms for up to 1,000 seconds. And we have enough time to study antimatter in our laboratory here at CERN.
Antimatter is the mirror image of matter, identical but with an opposite electrical charge, and destroys each other when they meet. Our universe is apparently made entirely of matter, yet at the time of the Big Bang, matter and antimatter would have existed in equal quantities. Particle physics labs like CERN in Switzerland can make antimatter easily enough, but it's proved almost impossible to hang on to and study because it instantly annihilates on contact with regular containers made of normal matter.
The antiprotons from the antiproton decelerator, that's the machine that we need here at CERN, come down this pipe right here. And they come into our apparatus, which is inside this large magnet. This is a very strong magnetic field to help to confine the charged particles that make antihydrogen.
Scientists are now working on trapping more anti-atoms at a time, and in doing so hope to find out why nature favored matter over antimatter at the dawn of the universe.
So now, as I told you, there were many attempts to study antimatter, but the main problem was how to confine these subparticles. As we know that in physics, when the antimatter collides with the matter, they both annihilate each other. But the scientists there at CERN, they invented this spinning trap device, and its scientific idea is pretty easy, by the way. It just requires the presence of vacuum inside of it and a very strong magnetic field. So the electrically charged subparticles are now forced to spiral. Can you imagine that there are magnetic field lines now, magnetic flux lines now passing inside this vacuum? So the electrically charged subparticles are now forced to spiral around these magnetic flux lines. So by this way, they were able to confine the subparticles inside the trap without annihilating with the matter. And in 2011, it was reported that they had succeeded in tracking antimatter for more than 16 minutes, and this was more than enough to study the properties and details. The potential uses of the antimatter. Well, of course, guys, such research and such processes of formation of the antimatter requires a lot of money, a lot of time, a lot of research. But is the antimatter really important? Is it worth you spending these millions, or in other words, billions of dollars on its research? Yes, it is considered. Antimatter has the greatest energy density of any possible fuel, which means that it has the potential to produce more energy per unit weight, more than any other possible fuel on our Earth. Because it simply obeys this Einstein's rule, which is E equal mc power of 2, which energy in E is represents the energy, M represents mass, and C represents the speed of light multiplied by 2. The scientific idea which is what? On burning any other fuel, not all of its mass is converted into energy. Some of its mass remains as waste, some of its mass is converted into gas, and so on. But in the case of the antimatter, all of its mass is converted into energy. And this makes it the antimatter has the greatest energy density of any other possible fuel. I'll show you some brief examples to show you how enormous or how gigantic the energy coming from this antimatter. 1 kilogram of antimatter could be used to create a 43 megaton explosion. And this is, by the way, is equivalent to the explosion coming from several thousand nuclear bombs. The megaton, it is a unit for measuring the explosive force. It is used for measuring the explosive force. 1 megaton is equivalent to the force of explosion coming from 1 million tons of dynamite. So can you imagine that 1 kilogram of this antimatter can produce an explosion which is equivalent to the explosion coming from 43 million tons of dynamite. This is of course enough to blow up the whole Gaza. And another example for the great energy coming from this antimatter, that 1 milligram of antimatter with 1 milligram of matter can deliver more energy than 2 tons of rocket fuel. And of course we know that the rocket fuel is considered the most expensive fuel in our Earth because it has the greatest energy unless we form the antimatter. But the problem is that the formation of this 1 milligram will take us, if we start creating the positrons at a rate 5 times faster than our current rate, creating this 1 milligram will take us about 200,000 years. So using this antimatter is still now not possible. But of course in the future we'll be able to create it much faster. Well, these are some of the references if you guys are interested in checking after me, or if you guys want to know more about the antimatter. I think this will be the end of my presentation for today. I'd like to thank Mr. Ahmed for giving me this opportunity to stand in front of you guys today. And of course, special thanks to my partner Muhammad Zari. He helped me a lot in gathering the information and making this presentation, but he just prefers to working behind the scenes. And by the way, he's a manager at Trust Techniques. He is a computer genius. Anything concerning computer and Wi-Fi, he knows about it. So if you need anything, I'm talking for you here. I'm telling you, he's a manager at Trust. What do you want to know more? Anyway, I'd like to thank you guys for paying attention for me today. I hope that you have enjoyed my topic. My main purpose of the topic wasn't that you know about the details of the antimatter, but just that you become aware of the existence of such things in our Earth. Just the idea that something like this antimatter presence now on Earth is just wow. Can't think like that. We can use it in the future. Can we be able to create it at a range faster than this? And of course, this price will go much lower if we start creating it. So thank you guys again for paying attention for me, and I hope you have enjoyed it. And I'll be glad to receive your questions if you want to know anything else more about it.
Okay, thank you, Ahmed. Let's give him first, I want to thank Ahmed and Muhammad Zari for their laborious effort, regardless to what they were explaining. And whether you understand every single word they were saying or not, we are here to test two things. First, our English skills and our public speaking skills. And in these 2 points, Ahmed skilled, Muhammad Zari skilled. You know what I mean? So in your feedback sheet, I want you to evaluate Ahmed and Muhammad Zari according to their English skills and public speaking skills. Okay? And the topic. Ahmed has done a very great effort to memorize such marvelous, such gigantic information and repeat them back in front of you. Okay? The least they need from you is your feedback now. You have 2 minutes to write